Unit 10, Day 1 homework tutorial. Your task is to complete the back even problems of this worksheet. So I'll work through the odd problems with you to help you understand how to apply the same concepts to the evens. Again, you're supposed to work on the back side, which starts with number 17. And you're supposed to complete the evens, but I will work out the odds. For number 17, it wants us to name the circle. To name the circle, all you need to identify is the center of the circle, and the center of the circle on the right is L, so this is circle L. Number 19 would like for you to name 3 chords. If you recall from our notes that a chord is a segment that touches the circle from end to end. So an example of a chord would be this, RS. Don't forget to name the endpoints, but also put the segment bar above it. Another chord would be ST. And then the last chord would be RT. Again, it's a segment that goes across the circle, and both endpoints are on the circle. It doesn't have to go through the center. Number 21 wants us to name a radius that is not part of the diameter. So a radius is a segment that starts at the center and then hits the edge. So LW would be a radius not part of the diameter. So LW. 23 says that RT is 19. RT, since it's a chord and it goes through the center, RT is the diameter. So the diameter is 19. It wants us to find LW. LW, we mentioned just above, was a radius. LW is that radius, and we talked about it in class that the radius is half of the diameter. So since the radius is the diameter divided by 2, that means it would be 19 divided by 2, which is 9.5. So the length of LW is 9.5 meters. Now it wants us to find the circumference. The formula for circumference from last unit, as well as this one, is C is equal to 2 times pi times radius, or you could use diameter times pi. Since we have both the diameter and the radius for this problem, it does not matter which one we choose. So I'll go with diameter times pi. So it would be 19 times pi is the exact circumference. But if you want to grab the calculator, you can approximate it. So we would type in 19 pi. Do not use 3.14, use pi. And it's approximately 59.69 meters. So 59.69 meters would be the circumference. But it's okay to leave it in the exact circumference, 19 pi. Just don't forget to label with meters. Number 25, or this next section of problems, we're asked to find the measure of each arc and determine if it's a major, minor, or semicircle. Oh my goodness. Why is it not hitting select like I want it to? Thank you. So arc ABD is 25. Let's highlight that arc. So you start at A, then travel to B, and don't stop until we get to D. So up above in the passage, it told us that AC was a diameter. So that AC is right here. And I mentioned in our notes that whenever you have an arc formed by a diameter, it measures 180. So that means that this angle here, the 50 degrees, and this angle here should add up to 180. So that means this one is 130. So I need that 130 plus the 50 plus the 100 to cover arc ABD. And so when I add all of those together, I would get 280 degrees. So since it is greater than 180 degrees, it is a major arc. Now for arc DEB, let's trace it. Start at D, go to E, and don't stop until we get to B. So again, AC is a diameter. So I'm showing 100 here and 30 here. So that's 130. So that missing angle should help it add up to 180. So that missing angle that's left on our circle should be 50 degrees. So this is 50 degrees as well. So I need this 30 here, this 50, and the 130 would make up arc DEB. So the 30 and the 50 is 80, plus 130 is 210 degrees. So again, it's greater than 180, so it's a major arc. And lastly, we're looking for arc CDA. So let's trace it. C, D, A. So start at C. I need the 100, I need the 30, and I need the 50. So that adds up to 180. Ooh, why is the delay doing this? I apologize. So it is a semicircle. For the remaining section, we're going to find the length of the arc and the area of the sector formed by the arc rounded to the nearest hundredth. We're using the same circle for all questions, so it's probably not best to write any of the information or extra information on the actual circle unless you're going to redraw the circle over and over again. So we're looking for the length of arc MR. Let me highlight it. Arc MR is this arc right here. I believe we were told that MT was a diameter, and it appears that way on the picture. So we can find the missing angles, this one and this one, because with the 50, it'll equal 180. And actually, we just need these two missing ones because those would be the central angle for MR. So 50 plus what is 180? It would be 130. So this entire angle here, let me show you with my pen. This entire angle is 130 degrees. So let's write down the formulas that we're going to need. For arc length, it was equal to the measure of the angle over 360 degrees times the circumference. So 2 times pi times radius. So for our situation, the angle is 130 degrees over 360 degrees times 2, sorry, I should have put a multiplication bullet, not equal sign, times 2 times pi times our radius. And the radius for this one, it says PR. Let's highlight that on the picture. PR is this segment here, and that represents a radius. So it's 13 feet, so that means our radius is 13. So to find the arc length, we'll grab our calculator now and type in everything we've presented. So what I would do, in one parentheses, I'm going to put 130 divided by 360. And in another parentheses, I'm going to put 2 pi 13. The calculator will know to multiply all that without actually putting the multiplication button. And so you get approximately 29.50 if we're rounding to the hundredths place. So 29.50 feet is this arc length, sorry. Area of a sector formula is pretty close to the arc length. The only difference for the area of the sector is that not only do you have the measure of angle over 360, you're going to multiply it times the area of the circle, which is pi radius squared. So the first fraction, 130 over 360, will be the same, times pi times 13 squared. So now we grab the calculator again, and here's a shortcut, ladies and gentlemen. If you hit second enter, what you just typed reappears. So the only thing I need to change is get rid of this 2 from the circumference and hit delete. Keep pi, but after the 13 I need to square it and then close my parentheses again. And then it'll give us the area of the sector, which is approximately 191.72 if rounding correctly. So it's 191.72. Is that what I said? Yes. 72. What's the units? Feet squared. Since we're dealing with area, don't forget to square your units. Alrighty. And last but not least, number 33. Same idea. We're finding MRS and PS is 10. PS is one of the radii. So I'm going to highlight that real fast. Here's PS. It's a radius and it's 10. And then we're looking for I can't remember. The arc. MRS. Okay. So it's this arc here. MRS. So earlier we had found this whole entire thing is 130. For MRS, we need that angle plus the 250s, which would add up to 100. So the total angle is 230. So again, for arc length, we're going to take this 230 divided by 360. Again, I'm on number 33. I just don't feel like scrolling back and forth, times the circumference, which is 2 times pi times radius, which is 10. They told us it was 10. PS was 10 centimeters. And then while I'm at it, in the same manner, I'll write out the equation for the area of the sector so that when I grab my calculator, I only have to put one thing at a time. So I won't have to keep changing between pin and select. So it's 230 over 360 times the area of the circle, which is pi times 10 squared. So now let's grab our calculator. So again, in one parentheses, I'm going to put 230 divided by 360. And then another parentheses, I'll put 2 pi 10. So the arc length would be 40.14. And for area of sector, just hit second enter, delete the 2, make this 10 squared, and close my parentheses again. So it's 200.71. So again, the arc length was 40.14. I believe we're in centimeters. And for the area, it's 200.70 or 71. .71 centimeters squared. And this concludes your tutorial for this assignment.